All right, we're going to start the last chapter dealing with the cardiovascular system. That's chapter 21, which deals with blood vessels. So let's look at the functions of blood vessels. So blood vessels, they're going to carry blood. They're going to exchange nutrients, waste products, and gases with tissues. They're going to transport substances. They're going to help regulate blood pressure, and they're going to direct blood flow to tissues. All right, so let's take a look at the structure of blood vessels. So looking at the different layers of the blood vessels. So the innermost layer, as you can see right here, is the tunica intima. It's also known as a tunica interna. So this is the innermost layer of a blood vessel. It is made of endothelium, which is simple squamous epithelium. And it's going to secrete chemicals that inhibit platelet aggregation, so platelets from sticking. Next is the tunica media. So here's tunica media right there. So the tunica media is a middle layer of a blood vessel. It is made of smooth muscle and elastic tissue, and it's much larger in arteries. A couple of terms you probably are familiar with. One is vasoconstriction. Vasoconstriction is a decrease in the diameter of a blood vessel, and that's going to increase blood pressure. So if we get the hole smaller, blood pressure increases. So here that smooth muscle is going to contract. And this is controlled by the sympathetic division of our autonomic nervous system. Next is vasodilation. This is an increase in diameter of blood vessels, so it opens up, right? If we open it up more, the blood pressure is going to decrease. And so here, that smooth muscle relaxes. So the last layer here is the tunica adventitia, so also known as the tunica externa. So this is the outermost layer of a blood vessel. It is made of connective tissue, and in some cases it can be serous membrane. So if it's in our internal, connective tissue like in our arms, but if it's in our abdominal pelvic cavity or thoracic cavity, there's a layer of serous membrane around it. Lastly, the last thing I want to mention here is the lumen, and that's the opening. So that's a central blood containing space. All right, let's take a look at blood vessels here. So let's take a look at arteries. So this is showing an artery. This is a vein right there. Now, arteries, this is a vessel that transports blood away from the heart. Most arteries are relatively high in oxygen and low in carbon dioxide. The exception here is pulmonary because that blood is coming from the right side of the heart, so it hasn't been oxygenated yet. It's going to the lungs. The movement of blood through the arteries is caused by ventricular contractions. So if we look at the types of arteries, this is showing the three different types. So the first are elastic arteries. That's the top one here. These are vessels that transport blood from the heart to smaller arteries. So this would be like the aorta. Next is muscular arteries. Muscular arteries are vessels that transport blood to specific organs. So they have a larger tunica media in them. All right. Next are arterials. So we see here is an arterial. So these are small blood vessels that feed capillary beds of organs and tissues. And then you see these little guys coming off of those, and those are called meta-arterials. And these are short vessels that link arterioles and capillaries. These guys a lot of times have these pre-capillary sphincters there, and these encircle the entry of the capillary, so they can reduce or shut off flow to those capillaries. So if we go to the next picture, showing that reduction in flow there, or cutting it off completely. All right. So let's look at some sense organs that we have. This is showing arteriosclerosis, so that buildup of plaque that occurs. You can see it's occurring underneath the endothelium. So looking at some arterial sense organs. So first are these carotid sinuses. So right up here, these carotid sinuses, they contain baroreceptors. Now baroreceptors sense pressure. All right. So they're going to respond to changes in blood pressure, and they are in our common carotid arteries. Next are carotid bodies, so we can see those little guys right there. Carotid bodies are chemoreceptors. So those are chemical sensors, and they're going to help monitor our blood composition. So they help our breathing in relationship to carbon dioxide levels and oxygen levels and pH levels of our blood. Next are aortic bodies, which we can see there, are aortic bodies. These are also chemoreceptors. They have the same function as the carotid bodies do.